Okay, in the last video, we learned how to differentiate a trigonometric function where we've got one function inside of the sine or the cos or the tan. For example, like this one here, we've got x squared, which is one function inside of the trigonometric function, the sine. And we learned that the way to differentiate this is to differentiate the big function, the function on the outside, so that gives us cos of x squared. And then what we do is we differentiate the function on the inside, which is 2x, and we multiply through. Okay, so we learned how to do that. But now what we've got to do is we've got to think about the reverse of that, which is what if we were to differentiate sine squared of x? Okay, so instead of sine of x squared, we've got sine squared of x. Now it's important to understand what this actually means. This means that we've got sine x all squared. Okay, so when we say sine squared x, we really mean sine x all squared. Now, what's the difference between this function and the previous one? Well, in this particular function, the sine x is the function that's on the inside, and it's inside of a bigger function, which is the x squared. Okay, so can you recognize that? So in the previous question, the x squared was the function on the inside, and the sine was the function on the outside. And in this question, the sine is the function on the inside, and the x squared is the function on the outside. Okay, so it's kind of like we've taken the function sine x and put it inside of the x squared. So if we were to differentiate this, how would it work? Well, it's actually the same principle as before. What we've got to do is we've got to differentiate the function on the outside first. So if we differentiate x squared, we get 2x. So we've got here sine x all squared differentiates gives 2 sine x to the power of 1, right? So we've differentiated the function on the outside to get that. Then we differentiate our function on the inside, the sine x, and if we differentiate that, what we get is cos x. Okay? We multiply these two things together. So what I want you to see is the function on the outside is differentiated to give 2 sine x to the power of 1. Then the function on the inside, the sine x, gets differentiated to cos x, and we multiply through. Okay, it's probably best seen with a few other examples. So let's try this again. Here we're going to have y equals, let's make it cos cubed x. Okay, what does this mean? This is the same thing as cos x all cubed, which means that we've got the function cos x inside of the function x cubed. So how do we differentiate this? Well, we differentiate the big function, the function on the outside first. So that's going to give us 3 cos x to the power of 2, right? And then we take the function on the inside, the cos x, we differentiate that to give minus sine, and we multiply through. So in the end, our answer is going to be minus 3 cos squared x times by sine x. Okay? All right, let's try another one. Let's just keep going. Let's say we had y is equal to, make it even harder, I think, tan cubed of 2x. This is very difficult because actually we've got a function inside of a function inside of another function. Let me try to explain that. This really means we've got tan 2x cubed. So if you want to imagine this, what's going on here is we've got the 2x is a function inside the tan function, and the tan function is a function inside of the x cubed function. So what we've got to do is we've got to differentiate the big function on the outside first, that is the x cubed. So if we differentiate that, that will give us 3 tan 2x to the power of 2. Then we've got to differentiate the function on the inside, which is the tan. The tan differentiates to give sec squared 2x. And then we've got to differentiate the function on the inside of that, which is the 2x, which differentiates to give 2. So in the end, if I was to simplify all of this, this is 6 times by tan squared of 2x times by sec squared of 2x. Okay? And that's about as hard as I think we will do today. Okay, guys, I hope that was helpful. I will see you again next time.